yesterday, you can't see them yet, because there was one irregularity that I have to deal with. But you can get your grade, I mean, I've got a list of your grades right here. It's up to you. I mean, some people are better off not seeing their grade before the lab practical. Other people, it doesn't make any difference. It's whoever you are and how you react to it. One of the TAs can give you your grade after the lab practical. I can give you your grade after, you know, the last 15 minutes after 10:05, I can give you your grade. It's up to you, whatever you want to do. But that was the range, and most people were right exactly in the middle of that range. The most common grade was right in the middle of this spread. There was one question that was a true and false. As I saw how people interpreted it, I thought, that's a bad question. So, you got credit for it. Everybody got credit for that question. It wasn't a good question. Lab practical. Remember, we started at 220, not 120. And if you think about it, I mean, there's a lot of material, but there's only going to be 33 total questions. So, if I recall, I think there's 6 or 7 from the body directions. There's 6 or 7 from the part about the brain and testing of the cranial nerve. And that's not, don't come saying, oh, well, cranial nerve number 2 is such and such. You're not going to see it that way. It's much more generic than you're thinking. You still have to be familiar with them. You need to have some basic ideas on all of that. And there's about 6 or 7 on that lab. On the reflexes, there's probably about 8 questions, and on the anatomy, there's about 8. So there's not any specific thing. Think of all the anatomical parts from last week's lab. Well, if there's 8 questions, you're not going to be asked 25 parts, obviously. And I think you'll find it to be realistic. I mean, there's nothing weird about it. In fact, it's probably, most of the questions are probably more basic than you're going to think, than you're anticipating. Anybody have any questions on it? So a minute per station, then you can have lots of time after to go back wherever you want. We're not going to push you out. Okay, where we were ending up last time, we were talking about ADH, and we said that ADH is affecting water balance. It determines how much we urinate, the volume of urination. If you drink a lot of the plain water, your body has too much water. If your body has too much water, that makes your blood too dilute, picked up by the osmoreceptors. They're always working. As you're sitting there right now, your osmoreceptors are functioning fully. And if they detect you have too much water, in other words, if your blood is too dilute, they're going to send the message, well, don't release ADH, and you're going to pee out excess water. If you're dehydrated, the osmoreceptors are going to detect blood is too concentrated. And if the blood is too concentrated, they're going to direct the message to release ADH so we can conserve water. And if you're dehydrated, just think about your own body. If you're dehydrated, you don't urinate a whole lot. If you are overhydrated, you urinate a lot. Just common sense reasoning about that. And we then gave an example of the world record for somebody whose ADH functioning or release was as low as they did, they released very little. And their urine production per day was 27 liters. I think I might have written 25, I don't remember, but anyway, it was 27 is the real number. People that have this condition where their posterior pituitary is damaged in some way, and they don't release enough ADH, that's a condition, it's got a name, it's called diabetes insipidus. Now, that's not the diabetes with which you're familiar. The one you're familiar with is called diabetes mellitus. Diabetes mellitus is the one related to blood sugar levels. Diabetes insipidus is related to an ADH issue. On exams, people tend to confuse these. And on exams, probably on the next exam, unless there's 3 or 4 people in this room, are going to confuse them. Even though I'm going to tell you now how not to confuse them. Okay, so look at those 2 words. Way to remember them and keep them apart. Look in here. We sip water. And hence, that's the one that's going to be dealing with water balance in ADH. If you remember that, you'll keep them straight. But 3 or 4 of you aren't listening. And you will confuse them. So you know ahead of time why you have red marks on those answers. Okay. The other hormone of the posterior pituitary we said was oxytocin. We have that written from last time. And what we're going to say about oxytocin, we'll talk about it later when we talk about reproduction. But oxytocin, there's 2 things that it mainly does. And it's mostly active in female. Males have oxytocin, but we are not clear as to what it does in males. In females, it's very clear. First action of it is that it causes milk release from breast tissue. When the mother is breastfeeding, it causes milk release. The word release there is important, as we will see at a later time. Not milk production. I'm not saying milk production. We're saying milk release. There'll be another hormone involved in milk production. The other thing that oxytocin does is that it causes the muscle tissue of the uterus to contract during childbirth, during labor. So uterine contractions during labor. Okay, now we turn to the anterior. Here's where, unfortunately, there's a lot of terminology and there's no way around it. But we'll try to make it sensible. If you pay attention to the words that are used, they do make sense. If you try to organize it in your head, it's very doable. but there's a lot of terms, but anyway, they're sensitive. So anterior pituitary, okay. This is the kind of a structure that we see. And what we've got here, just like in the posterior pituitary, now remember in the posterior pituitary, the hormones were manufactured in the hypothalamus. Posterior looked like this, sort of. This is hypothalamus here, this is pituitary, here's posterior, anterior. In the posterior, you should have this written down already, hormones were manufactured in the hypothalamus. They were transported down the axon to the ends of the axons. And they were stored in the ends of the axons in the posterior pituitary. So they're called posterior pituitary hormones, that's ADH and oxytocin, but they're made in the hypothalamus and stored and released from the posterior pituitary. In the anterior pituitary, the hormones are made in the anterior pituitary. That's a big difference. All right, so here, just like in the posterior, we have up here neurosecretory cells. So that would represent nuclei, as we have seen a couple of times before. Nuclei, remember, in the central nervous system are groups of nerve cell bodies. Okay, so here we have the cells, and now we've got axons coming down to the pituitary gland. All right, now, these axons end in a network of capillaries. And I guess we should do this. Let's put in here how this dips down. This is actually kind of like that. The hypothalamus actually comes down here, so this technically is in the hypothalamus. But anyway, down here, you've got a network of blood vessels. And then further down, you have another network of blood vessels. So it looks like this. The upper part, here they are. Here's the lower part here. Just a whole net of capillary, and they're joined by a vein. As this and this. Okay, the hormone secreting cells are these, located within those networks of blood, that lower network of blood vessels. That's the hormone secreting cells. So when we say, when we're talking about hormones of the anterior pituitary, here's where they come from, right here. Those cells. There are many types, more than I've drawn here, and we're going to be listing them. Many types of cells here. This is a little different story. Now, this works very, very differently than the posterior pituitary. These are the cells here that release the hormones, but to get those hormones released, you have to have releasing hormones. And this is where the terminology is going to come in. But be patient with yourself and follow the logic. It'll make sense. These are what produce the hormones of the anterior pituitary. Up here, we have a system. Here's neurosecretory cells. Those are producing releasing hormones. And those releasing hormones travel down the axon and are stored in the ends of the axon. similar to what we saw with the posterior. Not exactly the same though, similar. Okay, now, if the body needs one of the hormones from the anterior pituitary, you have to have a releasing hormone to release that hormone. So, if we need a particular hormone, let's say this one right here. Here's cells here that produce this. Then we're going to need a releasing hormone that's going to cause the release of that hormone. So here's the hormone. These cells produce releasing hormones. They're stored here. If the message is we need this hormone, a message is sent down through those cells, down to the ends of the axons. The end of the axon releases the releasing hormone into this capillary network, and then this blood vessel carries that down to the actual cells. This will make more sense in a few minutes. This is kind of like an overview of it. Now, this system here, these are very unusual in the body. There's only, I think, like 3 of them in our whole body. This is called a portal system. A portal system is a system that begins with capillaries and ends with capillaries. So here's capillaries here. Here's capillaries lower down, joined by a blood vessel connecting them. That is a portal system. And that is carrying messages essentially from the hypothalamus to the anterior pituitary. So this specific portal system is called the hypothalamo-pituitary portal system. Just look at the words. Hypothalamus, pituitary, portal system. Hypothalamus to pituitary. Portal system means it carries it by the bloodstream, beginning with the network of capillaries and ending with the network of capillaries. If you pick apart the expression, it's not hard. So, you've got blood coming in here. So this blood is coming from the rest of the body. Coming up our neck, up our carotid arteries. Various branching of the carotids. Blood comes in here into the hypothalamus. So these cells up here, these neurosecretory cells, are monitoring or measuring hormone levels constantly. And then they're responding based on what they measure. If you need more of something or less of something, they're going to respond. And then here, this is going to empty into the bloodstream. So here's blood coming in, being measured, concentration of hormone. Here's blood coming out that contains those hormones. Okay, now we're going to look at the hormones and releasing hormones that are involved. Here's where the list comes in. And unfortunately, there's no way around this one. All right. We're going to start off by writing down what are called the 6 classical hormones hormones of the anterior pituitary. 6 classical hormones of the anterior pituitary. These are the ones you're gonna find in every source. When we say 6 classical hormones, that's to separate, these are the ones that have been known about for probably 50 years, or more than that actually. And there's actually 8 hormones from the anterior pituitary, but the other 2 are beyond the scope of this course. So we're going to look at the 6 classical ones. The other 2 remaining ones have only been researched probably over the last 10 to 20 years. And we don't know nearly as much about them. We know a lot about the classical ones. Okay, here we go. First one. First one is called TSH. What that stands for is thyroid stimulating hormone. So in other words, that's a hormone that stimulates the thyroid gland. The second one, ACTH. What that stands for is this. Adrenocorticotropic hormone. So what does it do? Look at the words. Hopefully you'll eventually start following the reasoning that we're trying to use. You don't have to know what it does. All you need to do is you can figure out something that it does from just picking apart the words. What does it do?
Stimulates the adrenal cortex.
Stimulates the adrenal cortex. Third one. GH, growth hormone. Look at the word. What does it do? Stimulates growth, body growth. Then there's 2 here that we kind of put together. FSH stands for follicle stimulating hormone. Now, follicle, we're not going to talk about it now. Follicles are found in the ovaries. We're not doing reproduction at this point. We put it here because for your organization and understanding, this is where you need to have it. This is where it belongs. And the other one, LH, stands for luteinizing hormone. This is involved in reproduction. So we're not talking about it now once again. We put it in here because we're talking about the 6 classical hormones. We need to make a list of 6. You make a list, if you talk about 6 classical hormones and we only list 4, it won't make any sense. Okay, it's involved in reproduction. Now, these 2, since they are both involved in reproduction, they're going to stimulate the ovaries and testes. and testes are called gonads. You should know that word. Gonad means ovary or testis. So these two, since they stimulate the gonads, we can use this expression. Those are gonadotropins. That's a good word to know. Because we're going to use that word freely. All this means, tropic, remember, means to stimulate. Stimulate the gonads. Those are gonadotropins. And the sixth one is called prolactin, abbreviated PRL. Prolactin. If you pick apart that word, anybody see any root word in that? This fragment of it? No, lactation, yeah, that's what comes into this. And then the pro means beginning or something. That's the hormone that stimulates milk production, as we'll eventually see. That stimulates milk production, and oxytocin, we said, stimulates milk release. All right, so now we have the 6 classical hormones. So what we're saying is that those 6 are made by these cells here. There's different cells here, these aren't all the same. Each makes different one of those. Okay, here's where the 6 classical hormones from the anterior pituitary are made, right there. Not up above. Oh, but we said that for these cells to produce and release hormones, you gotta have a releasing hormone. So now the terminology expands quite a bit. You look at TSA, okay? Thyroid stimulating hormone. You could call that a thyrotropin, because thyrotropin, tropin always means to stimulate, and thyro means thyroid. So a thyrotropin stimulates the thyroid. Okay, so we name the releasing hormone that stimulates TSH. We're going to call that TRH. Thyrotropin releasing hormone. TRH stimulates the release of TSH. The name, we're going to set another column here. They're going to kind of match this column. And if you approach it that way, it's not hard at all. You know, at least it's logical. Okay. ACTRH, that's a hormone we said that stimulates the adrenal cortex. Well, to stimulate the adrenal gland, that's kind of a corticotropin. Cortical referring to adrenal cortex tropin. So here we use CRH. Now, these two are abbreviations. If you take a book that's more than about 20 years old, these terms are going to be a little different. Don't write this down. I'm just trying to explain something. Books older than about 20 years, they're going to, instead of this, they're going to use this term. ACTHRH. And they decided just to combine this adrenal cortex. Here, they decided to just simply reduce that to the C. Anyway, ACTH is the C. So, like I said, okay, growth hormone. Logical name for this one would be GHRH. Growth hormone releasing hormone. These two here are called, we said, gonadotropins, and the same releasing hormone works on both of those. So if that's the case, it's logical to call this GnRH. Gonadotropin releasing hormone. When we get to reproduction, the GnRH, that expression we're going to use probably at least 20 times. And the last one. The last one does it a little differently. You would expect prolactin releasing hormone. Yeah, that exists, but to a small degree, it's not that important. Prolactin is caused by and controlled by inhibiting hormone. We call it PIH. Prolactin inhibiting hormone. Well, that has another name to it. The other name you have heard is this. It's also called dopamine. You see, if you go back over a span of 50 years, you find that our knowledge has increased dramatically over that time. But if you go back, in a lot of cases, it was thought that there's a lot of different hormones for everything. And then as technology improved, it was shown that a lot of these different hormones, as people thought, aren't really different. They're the same. You go back 50 years in the literature, right in here, you're going to find FSH-RH, and you're going to find LH-RH. Well, it was shown that it's the same hormone that stimulates both. So the terminology has evolved along with technology. So if prolactin is controlled by an inhibiting hormone, that says that prolactin release is most of the time inhibited. Does that make sense? What's the logic there?
So we don't feel good all the time?
So we don't feel what?
So we don't feel good all the time?
No, this is based, the prolactin part is based on milk production. I know what you're saying, you're taking it a different direction. Now, we want to go with the idea prolactin involves milk production, so how do you reason this out?
So we don't produce milk all the time.
So you don't produce milk all the time. So if you're a female, you don't want prolactin released all the time. If you did, you'd be producing milk your whole life. So it's controlled by an inhibiting hormone. In other words, we're inhibiting prolactin release. So now, what would be, going on that reasoning, what would be the logical stimulus to get prolactin release? Pregnancy. And the baby trying to nurse. And that's what we'll eventually see, that is the way it works. All right, now, all of these are controlled by negative feedback systems. Negative feedback is an expression. It's another one of those great generic words. Remember, we've used some of them so far. What's one of the good generic answers that we've used already? You know, if you don't know the answer, what should you say?
Depolarization.
Depolarization, if you're talking about the nervous system, very good. This is another one, negative feedback. Because almost everything works on negative feedback systems. Hypothalamus is another one. Yeah, those are I think the two that we've said so far. This is number 3, negative feedback. What controls whatever? Negative feedback. And odds are 90-some% you're gonna be right. So we need to talk about a negative feedback. You need to understand negative feedback clearly. Because negative feedbacks are gonna be involved in every system of our body. And we're gonna be talking about negative feedback and the understanding of it very, very much. Okay, good example, best example, your go-to example, if you're trying to remember what negative feedback means. There it is over there on the wall, below the cloth, to the left of the door. There's a thermostat. Perfect example of negative feedback. Let's see how it works. Negative feedback, we have what is known as a set point. In other words, the thermostat is set at a certain point. The point is the temperature that this room is thought to have as an ideal temperature. This is controlled by some mysterious person, we have no clue. There's thermostats in this building all over the place, but they don't work. We have no control. If something is too warm, we can't make it cooler. If it's too hot, if it's too cold, we can't make it warmer. All of a sudden, this changes. And we have no clue. It's a big mystery. Okay, but it is a set point. I'm guessing in here the temperature is probably set at about 70-ish. Let's say that represents 70 degrees. Okay, this building, yeah, it's a modern building and it's insulated, probably fairly well, but not perfectly. Nothing is insulated perfectly. So, last night the temperature dropped into the 50s. So this building loses heat through the wall. The wall conducts some heat, just like in a house. So that set point starts to go down. Temperature in the room, the set point doesn't go down, the temperature in the room goes down. We set it at a set point, 70. Temperature starts to drop. Okay, the thermostat picks up on that. The thermostat, what it's doing, its purpose, is to measure how much the temperature dropped. And we call that the input. The input to the system is how much the temperature deviates from the set point. Now, this example we're going through, after we're done with it, we're going to say hormones work exactly the same way. So this is a very relative example, and it's your best go-to example if you're trying to figure out something on an exam. Okay, that's the input. So what's the if the thermostat is detecting too low of a temperature in here, what's the message it's going to send out? Produce more heat to the heating units in this building. So heat is going to be produced, and this is going to then go back to the set point. So the heat produced equals the output. The output of the system is heat. Now, let's define negative feedback. The definition will get you through anything involving negative feedback. There it is. A system in which an increase in the output causes a decrease in the input. An increase in the output causes a decrease in the input. Never forget that. Never. If you do, it will come back and haunt you repeatedly. Guaranteed. One year on exams in this class, on the second exam, I had a short answer, and the short answer was, discuss the meaning of negative feedback and give an example. Okay? Lots of people missed it. On the third exam in the course, I had the short answer question, discuss negative feedback and how it works and give an example. Probably 75% of the people that missed it on the first exam missed the same question on the second exam. And I kept telling them, you should know this. On the third exam, I had this real creative question. Short answer, discuss negative feedback and give an example of it. At least half the people that missed it the first time missed it the second and third time. I don't know how else to emphasize it. But think about that. Those people missed the same question 3 times. That's pretty costly when you do that. Okay. So you can summarize that definition like this. Output controls input. That summarizes that definition. Output controls input. For those of you, and that will be 4 or 5 of you on the next exam, what you're going to do is you're going to, and you'll write it down, you're going to say input controls output. That's wrong. Output controls input, because look at this. Here's the input. Okay, the heat produced, which is the output, that controls this because as more heat is being produced and let into the room, notice what happens to the input? Disappears. So output is controlling how this deviated from the set point. Output controls input. What happens in the summer? In the summer, okay, you got a set point. So heat comes in through the walls. So rooms in the building get warmer. Remember, input is deviation from the set point. Here, this would be the input. How high it went. The output is the reducing of the temperature. This comes back, not just the opposite of that, but output controls input. The output is the cooling, which reduces how warm the room is. Every negative feedback uses exactly this reasoning. Every one. That's why I keep emphasizing, you need to understand negative feedback. Okay, now all we're going to do is we're going to transfer this idea into this first hormone that we have listed. And the way to do this, and we'll be doing it all the time, is to do flowcharts. Flowcharts make this real simple to understand. And the simplest example is the one with thyroid hormone. Okay, now, we're gonna start off. We know that the beginning has to be the hypothalamus. And many of them will be that. All right, from what we have seen here, the hypothalamus, what is it going to release? Already talked about this, just in slightly different words. What's the hypothalamus going to release?
The thyroid releasing hormone.
Right over there. Okay, what's its target tissue? What's the target tissue of TRH? No, you're close, close. Target tissue. It's releasing the capillary, but what's the target of, where do we want TRH to go?
Anterior, posterior.
Causing the anterior pituitary to release
TSH.
target tissue of TSH. Causing the thyroid to release, at this point, we're going to just say thyroid hormones. Okay, now, when we do these, we put plus signs to mean stimulate, negative signs to inhibit. So TRH stimulates the anterior pituitary to release this. TSH stimulates the thyroid to release thyroid hormones. Now we have a negative feedback. The negative feedback goes like this. And then we're going to put a negative sign on it, indicating negative feedback. All right, this example is no different in concept than what we have over there with the thermostat. We want the thermostat, when that's set, the set point keeps the room at about the same temperature all the time. This is going to keep thyroid hormones in our bloodstream about the same all the time. Same concept. Conceptually, it's the same idea. So the negative feedback is this. The hypothalamus is monitoring thyroid hormone levels. It's measuring them all the time in our body. If the level goes down, hypothalamus releases this, which causes this chain of events. Thyroid hormones are released, but then that negatively feeds back to turn this down. Same thing with the room temperature. If it's cold in the room, you want the temperature to go up, so you want the output of heat. The temperature goes up. Well, you don't want it to keep coming up. You want it to go up until you get the room at a normal temperature, then you want the heat to shut down again. In other words, you want to maintain the temperature here. Same thing here, we want to maintain these. It's gonna be the same with all these hormones. We wanna maintain constant levels. That's the reason. This is probably the simplest example of a negative feedback that we'll be talking about. Questions? So,